Hi everyone. Today we're going to be walking through a demo of creating a ClickPipe between TimescaleDB, an extension of Postgres, and ClickHouse. Here I have a simple Docker Compose script which sets up a TimescaleDB instance, and I'm also setting various settings pertaining to Postgres logical replication, which would be needed for the ClickPipe. Heading over to Timescale, I have this VM here where I have these various scripts for ingesting data, showing chunks, and so on. So heading over to Postgres, what I'm going to do is I'm going to run this script for initializing timescale. And looking at what this script does, it basically creates the TimescaleDB extension on Postgres, and it also creates this table sensor events, which has an ID, a timestamp, a device ID, and so on. It also creates a hypertable on timescale. So in timescale, you have these hypertables, which are tables which have these chunk tables under the hood, and these chunk tables are partition tables based on timestamp, and you can also set the if you're partitioning based on time, you can set this chunk interval, which I've set to as 10 seconds, and the script also pre-populates this sensor events table with 1000 rows. Talking more about the hypertables and chunking in timescale, I have the script to basically get the chunks for this table which we just created, and I'm showing 5 chunks here. So just like regular partitioning, you have these chunk partition tables with a start range and an end range, and all of them are in this TimescaleDB internal schema. We can take a look at one of the chunks just to see what each one of them looks like. So here you can see it's the same schema as our parent table, um, but the way TimescaleDB is different from your regular Postgres partitioning is that it abstracts a lot of it for you. It creates partitions automatically. It creates if you create an index on the parent table, it creates the index on the children for you. You don't have to do that. It also comes with various time bucketing functions. It does aggregations and so on. So now that we have these chunks, let's see how many chunks we have in total. So as you can see, we have 100 chunks, and that's because of the way I've set my chunk interval and how I'm inserting the data. So heading over to ClickHouse Cloud, let's create a ClickPipe, and you can do that by clicking on data sources, going to get started, and clicking on Postgres CDC. I filled out all the details here, and we can go on to the next step, which is configuring certain things for logical replication. One of the key things here is the Postgres publication. So as I mentioned earlier, because Timescale has this concept of hypertables with chunk tables under the hood, the way you would create your publication is along with the table you want to move, you also need to include all the tables in this TimescaleDB internal schema, which would be the chunk tables. So that is exactly the publication I selected here. You can also configure some other settings for the syncs. I'm going to set the sync interval to 10 seconds. Moving forward to picking our tables, I'm going to create a new database on ClickHouse. And here you can see timescale comes with a bunch of these various schemas, and you can see the TimescaleDB functions and so on. But we just need to replicate our sensor events table here. In the ClickPipe, there are a lot of tweaking you can do. You can exclude columns. You can change the engine of the target table on ClickHouse. You can set custom sorting keys and so on. Heading over to the final step, here you can just select the full access role and create the ClickPipe. Upon creating the ClickPipe will first provision whatever underlying infrastructure it needs for the ClickPipe. After which it's going to head over to timescale. It's going to get the table definitions of your source tables, using which it's going to create the target tables on ClickHouse. After it does that, it's going to run initial load, which is the 1000 rows which I just pre-populated the table with. It's first going to move that table over, as you can see here. We could even take a quick look at the table on ClickHouse. As you can see, here are our 1000 rows. And if we take a look at the table schema, You can see it's a replacing merge tree. We have all our columns along with some PDB metadata columns. And the ClickPipe also chooses, it creates the primary key and order by as your primary key on Postgres. So heading back to the ClickPipe, um, now that initial load is done, we are in a phase known as change data capture. So on timescale, I have this script to basically ingest, some rows into the sensor events table. So here I've inserted 100 rows. And if we take a look at the number of chunks one more time, you can see that now there are 200 chunks. So just as before, because of the way, I've set the chunk interval and how I'm inserting the data with the timestamps, that's resulted in 100 more of these, chunk partition tables. And the Postgres ClickPipe has logic where when it sees new chunks coming in, it maps those new chunks to the parent table, which allows us to pick up the change data here and sync it over to ClickHouse. So as you can see, there are 100 rows synced. We could even verify it by heading back over to ClickHouse to our sensor events table. And you can see there are now 1,100 rows. So that's a high level view at how to set up a data pipeline with the Postgres ClickPipe between TimescaleDB and ClickHouse in very seamless steps. We have an extensive setup guide here for setting up this ClickPipe with all the TimescaleDB specific instructions. And if you have any other questions, you can reach out to DB integrations team here at ClickHouse. Thanks.